Welcome to the Society of Amateur Radio Astronomers. Radio Astronomy, Constants, Variables, and Formulas. Lesson 16, Velocity Factor, the speed of light in a coax cable. Here's velocity factor. First, let's look at electromagnetic radiation. It travels in free space at the speed of light, which is approximately 3 times 10 to the 8th meters per second. Light travels slower in a medium, however. In a coax cable, the percent of speed of light in a coax cable is referred to as velocity factor. To find the cable length for one wavelength, you take the wavelength in free space times the velocity factor. This is a chart of representative coax cables with their velocity factors. Let's do an example problem. Coax type of RG59 with a velocity factor of 0.78 and a frequency of 20.1 megahertz. What is the cable length required for one wavelength? In free space, the wavelength is equal to the speed of light over frequency. So that's 3 times 10 to the 8th meters per second over 20.1 times 10 to the 6th per second is equal to 14.92 meters. One wavelength of RG59 cable, however, the cable length would equal one wavelength of free space times the velocity factor, which is 14.92 meters times 0.78 equals 11.64 meters. Let's do a second example. Coax type is RG66 now. The velocity factor is now 0.66, and we keep the same frequency of 20.1 megahertz. Note, this is the same frequency used for radio Jove. What is the cable length required for one wavelength? What is the length of a 90-degree and 135-degree phase cable? In radio Jove, these phase cables are used as delay lines to steer the beam to find Jupiter at different parts of the year. So in free space, wavelength is equal to C over F. It's equal to 3 times 10 to the 8th meters per second divided by 20.1 times 10 to the 6th per second is equal to 14.92 meters. One wavelength of RG66 cable is equal to the free space wavelength times the velocity factor, which is 14.92 meters times 0.66 equals 9.85 meters. To find the phase cables, phase is referenced to one wavelength is equal to 360 degrees. So a 90-degree phase cable is equal to 90 degrees over 360 degrees times the cable length for one wavelength. So that'd be equal to 1/4 times 9.85 meters. It's equal to 2.46 meters. 135-degree phase cable is 135 degrees over 360 degrees times the cable length for one wavelength. It's equal to 0.375 times 9.85 meters equals 3.69 meters. If you like this video, like and subscribe. Join SARA to start your hobby of amateur radio astronomy. Go to our website at www.radio-astronomy.org. Thank you.